And of course, keep one for yourself. Are you running out here?
Oh wait.
They are going round. Morning! Hang on. You get special service. I missed you yesterday.
I watched the live stream.
Silly boy didn't wake up.
I didn't wake up, but then I did watch the live stream.
I slapped his head.
Hey, you didn't.
I did.
Does that give you something?
Go over that.
You should give it a try.
No, I'm not.
You're allowed to? Did you get told off?
Oh.
I won't tell you.
The told off. Yeah. Tell you what, take them up there. Spread the word. I'm very well, thank you. You want one as well?
You could get two.
Should be, but not two for you.
No, one for me, one for a friend. Thank you.
Lovely, thank you. You want one? Get one.
I got it.
You want anything else then?
Thank you.
Your friend is too late. Come. Good morning. Has everybody got a manual? Yep. Anyone without? With or without you. No, better not say. Right. My wife says, don't give up the day job. Which I think is pretty mean. Oh. Wait. Wait. What do you think? You guys want the manual for the project?
Awesome. Thank you.
Thank you, thank you. Do you want, you're welcome. Right, let's make a start. Good morning, everybody. And welcome to this pre-lab session. I think there's attendance monitoring, so please go to your device, do the usual nonsensical bit, sign in. In this session for the BI 301 module, the enzymes and skills, I want to briefly go through what this practical is all about and what you're going to do next week. And then in the following sessions as well. Do you want that? You've got one? Good. I've got more than over there. And, oops. Good. Right. This practical is different to the ones that you've done before, because so far you got instructions for one practical, you then did the practical, followed the instructions more or less, and then you had to do a write-up and hand it in the write-up. This was marked, and and that's not how it is in real life when you are a scientist. When you are a scientist, you have basically a little project where you not necessarily do one thing and then it's done. And I spent quite some time in trying to figure out how can I make this as real life as possible for you guys, so that you get a flair of what's going to hit you, for example, next year, and then, most importantly, in your final year. Because in your final year, you are doing projects, real, true, big projects. Good afternoon. Do you want... Got two here. Do we have more? Yeah. So this practical will look at the enzyme lactate dehydrogenase, just simply because it is a nice, sweet little enzyme where we can sort of do the things that we have already established in the lectures, in the theory. You see the reaction that is catalyzed here. So we have pyruvate, and we will discuss about this reaction quite extensively. We have pyruvate, and with the help of lactate dehydrogenase, LDH, pyruvate is converted into lactate. It is basically an oxidation reduction reaction, and this is done with the help of NADH. This is a cofactor for LDH, and we can very easily measure how active the enzyme is, not by directly measuring the concentrations of pyruvate or lactate. They are a pig to measure directly. But what we can measure very easily is the concentrations of the cofactor of NADH. Because NADH has a very characteristic absorbance at, I can't remember what wavelength, at wavelengths of 340 nanometers. So what we do is basically we incubate pyruvate in the presence of NADH, and when we add the enzyme, what we will find is that pyruvate and NADH are consumed, so the absorbance, the concentration of both go down. We only measure the change in concentration in the NADH because we can assume that it's a 1-to-1 ratio. For each molecule of pyruvate, we need 1 molecule of NADH. And what we will see is that the absorbance of NADH goes down. That's basically the background to the experiment. It's not terribly exciting. So how does this practical work? Next week, either Monday or Tuesday, you go into the lab, and so that's week 16, and you get the data for experiment 1. And I will go through experiment 1. You've got it also on your handout. And this is compulsory lab. Without being in the lab, you won't get any data, right? Which makes it a little bit difficult to analyze. If people are absent for a valid reason, you need to fill in these concessions forms, and then you're mine. Right? No, I don't want to scare you. I just want to say I will then give you data, and you want to avoid that. You want to really work with your own data. You can work in pairs, but then the submission is your individual ones. Yeah? Okay, so in this next week, you get the data that you will that you will use to determine Km, Vmax, Vmax over Km, and Kcat, the turnover number. Forget the last bit. We are not going to do Kcat over Km. I don't know what possessed me when I wrote this. We just ignore that. We don't need to do that. So you collect the data, and I would strongly, strongly recommend that you analyze the data and have a look at the data. What do these data tell me? And you see in the, I've set up a website for that, and you see in the top right-hand corner, there is also a tab of data analysis, and it talks you basically through how you are going to analyze your data, right? However, I would suggest that next week you start looking at your data and say, oh, right, that looks weird, or, well, data don't look too bad. I will go through the data in a minute. What you should see and what you shouldn't see. The week 17, you don't have a practical. God knows why not. I have no idea. It would make sense, but what makes sense in these crazy times? Not a lot. In week 18, I and some demonstrators will be in the lab. If you have any questions or if you feel that you want to repeat this experiment from week 16. So if your data are absolutely shite, please feel free to come along, repeat the experiment in week 18. Yeah? Or if you have questions about the data analysis. So ideally, I don't want to see you. Nothing against you guys, yeah, but you are all lovely. But hopefully everything goes well and you understand what you're doing. You are then doing another little experiment, an add-on experiment in week 19 for an additional part of this characterization, of LDH characterization, and again, that is compulsory. You need to do that in order to get everything done. You will find that this experiment in week 19 will take you, how much time does it take? 3 times 1.5 minutes. So let's say 10 minutes, max. Yeah? So what on earth are you going to do with the rest of your time in week 19? Well, you will write up your results from week 16 and week 19 and hand both in at the end of your lab, week 19. Right? Now, if you are smart, you have done already everything from week 16. And actually, I expect you to do that because I expect you to give me the data in a special summary sheet. I'm not giving you the summary sheet today because I know what you're a lot like. You lose it, and I have to print it out again. So you get the summary sheets next week, yeah, in the practical. So if you are smart, you gather your data next week, you already start filling in the data sheet, the summary sheet, do your analysis, and if you've got problems, you see the demonstrators or myself in week 18. Week 19, you then just simply add this little bit of additional information and calculation to the summary sheet and hand in your stuff. And as they say, Robert is your mother's brother. Bob's your uncle. Job done. Yeah? Write up for this practical actually entail? Well, let's look at the summary tables. This will be actually your summary sheet that I want to see. That's all that I really, that I will look at in the first instance. So, Ben, do me a favor. No more 5,500 word introduction, please, right? I don't want to read an introduction. I just want to see what you got in terms of measurements. Okay? And all really I'm interested is the numbers that you get. But of course, if you mess up somewhere, it would be unfair if I say, oh my God, you are out by a factor of 10,000, right? So you get 0. So what I also want to see then from you are the data that you collected. And as I said, you will get the data sheet, so you just fill in the data sheet and you draw some graphs. Right? So these are the data sheets. There's also a link then, and you can scan it. What I did, because I'm a nice person, well, so I believe, I've given you some mock data that I just simply made up to talk you through the different calculations and what I want you to do, right? Now, trust me, I know what the data are, so if a student gives me exactly the same data, I will notice that. Yeah? So please don't do it, and you have to produce your own data anyway in the data sheet. So, yeah. I might look stupid, I might be stupid, but I know when people use exactly the same data, so please don't do it. So here are basically all the calculations that you would need to do for that. And as I said, best thing to do it is do that before week 18, because if there are any problems or if you have to repeat the experiment, you can do it very easily. You can ask us. Don't do it in week 19, because in week 19 I expect you to have all the data there, and the data from week 16 need to be presented nicely, computer generated. So you would need to use Excel. If you don't like it, suck it up. You have to use it. And certain things you can't, yes, you can do without Excel. Bless you. You can do without Excel, but it will make your life a misery if you don't do it with Excel. If you do it with Excel, it will cost you 20 seconds. If you don't use Excel or a related program, what's the technical term? You are screwed. So you better get used to it, but I've got tutorials for that. So you just simply go through the tutorial and it gives you all the things. Do you have any questions? And then the stuff or in week 19, the little experiment that takes you 10 minutes, that is what you do by hand. But I want to see the calculations and how you get these numbers. Does that make sense? Yeah? Do you have any questions about it so far? No? Logistics sounds reasonable? Brilliant. So, what are you going to do in experiment number 1? Experiment number 1 is very, very easy. You prepare 1, 2, 3, 4, 5, 6 solutions. 6 substrate concentrations. And you have to basically calculate how you do that. I give you an example. You are presented with 2 solutions in the lab. So you are presented with a 1.25 millimolar pyruvate solution and a 0 millimolar pyruvate. So basically, there's no pyruvate in that solution, but it contains the right buffer. And for example, you need to prepare 10 milliliter of a 0.125 millimolar pyruvate solution. So now you have to calculate how much of this stock solution do I have to use to get this. You can very easily use the equation C1V1 equals C2V2. And in this case, you can say, okay, I want 10 milliliter of 0.125 millimolar solution, and my stock is 125 millimolar pyruvate. So if you put that into a calculator, and even I can do that in my head, what do you get? How many milliliter of stock do you need when you do that? Loud? Thank you very much. So you need 1 milliliter of 1.25 millimolar pyruvate plus 9 milliliter, because you want 10 milliliter in total, plus 9 milliliter of the solution with no pyruvate. The reason we don't just simply use water is because the pyruvate, the solutions are, and the reaction is in a special buffer so that the pH does not change. If we add different amounts of water to our solution, we would change the concentration of the buffer in which it is, so we would get weird results. What we are basically doing here is we are using, instead of water to dilute, we use the pure buffer to dilute it. So that here, this solution of 0 pyruvate is just a plain buffer. Yeah? So don't dilute things in water, use the provided 0 millimolar pyruvate. Make sense? Good. So once you have prepared your solutions, you just follow the instructions. You pipette 2.7 milliliter of the appropriate, and you have to calculate that. If you are smart, you already calculate that in advance. You then pipette 2.7 milliliter of the appropriate pyruvate solution, so final concentration of, let's say, 1.25 millimolar, into a cuvette. The spectrophotometer is set to 340 nanometer, and at that point you zero the instrument. Yeah? Zero it. It should read 0 when you have your pyruvate solution in it. You then add 280 microliter of the NADH solution. And what will happen is that your spectrophotometer reading, the absorbance, goes up. Quite significantly going up, because NADH absorbs the light at 340 nanometers. That's good. Don't panic. That's exactly what it should do. Don't zero it at that point, because you want it high. You then add 20 microliter of the enzyme solution, mix well. Vigorous mixing, as quickly as you can, put the cuvette back in, put the enzyme solution back on ice, because if the enzyme gets too warm, it decides not to work, it denatures. What you then do is you have a stopwatch, put the enzyme with its solution in the cuvette into the spec, make sure you put the cuvette the right way around, and then every 10 seconds you take a reading of the absorbance. This is, the enzyme is using the NADH and the pyruvate, and therefore the concentration of NADH should go down, and of course the concentration of the NADH goes down. And of course the absorbance of the NADH goes down. Now, the more substrate we add, the more pyruvate we add, the faster the enzyme will work. So what you see is that at very low pyruvate concentrations, the going down is sort of really slow. At high concentration, you will see going down is fast. The gradient is pretty steep. You observe this for about 90 seconds. Yeah? Once you've done, and you write down, every 10 seconds, you write down the reading for it. Once you've done it, you measure the next concentration. So you start, for example, with 0.06125. You go to the 0.125. Do exactly the same. Put it in the spec, 0, add the NADH, observe where you start, mix with the enzyme, and record every 10 seconds the absorbance. Yeah? Happy with that? Do this for every concentration of pyruvate. This is experiment 1. You do that only once. So you have 6 reactions. Each reaction takes you 90 seconds, let's say 2 minutes. So ideally, you should be out within 15 minutes next week, right? I know that people are faffing around. They want to repeat it, that's fine, yeah, so that it looks good. What should your data actually look like? If you do that in Excel, you should see a graph actually like that. Well, first of all, you would collect the data in this table, and you will get this table in the summary sheet. So time, second, let's go for the second column, 0.06125 millimolar. I recorded the absorbance, 0.767, then it goes down 20 seconds, 0.734, and so on and so forth. Got that? Yeah? Happy with that? You then use the data, and for each concentration that you measure, you do one graph in Excel, and you show me how nicely your data are going down. Ideally, you will find it is a straight line, and from this straight line, you can calculate the gradient. Actually, you can see already the gradient if you use the trendline function in Excel, and there's a YouTube video, a tutorial how to use that, but you have done that before, I guess, yeah, so that's not a problem. So you see, yes, everything is kosher. We don't have to worry about anything. So why on earth do it? That should be the idea. That should be the standard case. There might be situations where things are not that nice. You might come across two different scenarios. So here we have time. Here we've got absorbance. And the ideal case should be a straight line. You might come across a situation where your straight line goes like that. It's not a straight line, actually. It means at the beginning, the enzyme is not doing anything, or hardly doing anything, right? This usually, and then after a little while, it starts working properly. This indicates if you've got a sort of a plateau phase or something where it looks like something like that here. This indicates that there was a problem with the mixing. The enzyme doesn't have access, and only through diffusion then things happen. So, which part of the line should you use? Should you do a best fit line? No, don't do a best fit line, because very clearly this starting part is not representative. So you would need to exclude that from your analysis, because that is just an artifact. Make sense? And you need to check whether you have this mixing problem. Another problem that you might encounter is something like that. Everything goes well, and then the enzyme does that. This is indicative that the enzyme is running out of substrate. You will find that potentially at high substrate concentrations. The enzyme is just simply running out of substrate because it's so efficient. Again, we totally exclude this part then from our analysis, and we just simply go from where it shows a straight line for our analysis. Okay? Happy with that? Can you do that? You then get your data table. And what you then do is, so you've got your change of OD for a defined substrate concentration. You now need to convert the OD into concentration, and you do that with the Beer-Lambert law. And I've given you an example how to do the calculations for that. And you fill in the next table. So you then have your pyruvate concentration in the first column and the change, but now in molar per minute or micromolar per minute in the third column. And these are the data then that you use to construct a Lineweaver-Burk plot. And you know how to do that. Again, there are tutorials. In order to determine Vmax Km and Vmax over Km. And you also need to construct an Eadie-Hofstee plot. And again, tutorials, you know how to do it. You then need to do a regression analysis, but you only do the regression analysis from the Eadie-Hofstee plot. Do not use the Lineweaver-Burk plot for the regression analysis, because that gives you nonsense. Only do it from the Eadie-Hofstee plot. And again, there is a tutorial how you can do that in Excel. Calculating the turnover number and the catalytic efficiency. No, we just do turnover number, forget the catalytic efficiency. You just simply follow the steps. Happy with that? Do that at the end of the practical next week, or at home, because then you have Excel hopefully at home. Check, do your data look all right? If not, come back to the lab or in week 18. If you've got questions, go to the group chat, hit me, or come to the lab week 18. Either repeat the measurements or ask questions. Week 19, you do a different experiment, which is basically experiment 2. You just repeat this experiment, but only at one very high substrate concentration, which then allows you to calculate the specific activity. End of week 19 practical, I get your summary sheet with some model calculations, with the printouts of your Excel graphs. There's no stress in writing up. I don't want to see a word limit or anything like that. I'm not interested in that. Ideally, there are no words apart from your name on the sheet. Problem solved. Okay? Happy with that? Yes, we? Thank you very much. BI 308 will start at 12 in KLT1.